Can everyone hear me? Okay, so this is good. So could I get a quick show of hands who is in the sciences? Okay, actually quite a few people, good. And then who does work with like government data? Okay, that's like quite a bit too. All right, well, so I'm going to talk to you about messy data, and I actually came up with a way better title that I should have put there first. But so I'm Ali Akmanalp, and I'm originally from Istanbul, Turkey, and I work at Harvard University, and I work at the Center for International Development. And we study developing countries. So we look at why certain countries develop well and other ones stagnate. And so you'll see why we have to deal with a lot of different data sets that weren't created for us. And so here's an example. I was working on this data set that was like a social security data set. And so what I wanted to get out of this was like people and where they worked. So what kind of job they did. This country that shall not be named, so they came up with a system where it's like an online thing, and you go, and when you're paying your social security taxes, you put your economic activity. So it says right there, actividad económica. And so I was processing this data set, and I saw like a bunch of weird things. Like the codes were all wrong, and there were like all these values. And I looked up this form, and like I see a text box right there, and I'm like, uh-oh, like something bad's gonna happen. And right next to it, it says, okay, list of economic activities, and it's a link, and you can click on it. And it gives you this PDF. It's a 40-page PDF that you have to like scroll down and find exactly what it is that you do, take the code, stick that back into here, right? And do people do that correctly? No, they do not, right? Okay, so I'm like, oh, right? And it's like, what do I do? So import pandas. So what's pandas? Pandas is basically fancy tables, right, with NumPy. So any kind of tabular data you have, you can kind of like shove it into pandas really easily and do all kinds of cool transformations and processing stuff with it. Or as I like to call it, Excel on crack. And so as I'm going to go through this talk, I'm going to give you examples of like, some of my examples are going to be based on this like actual real life data set that was gathered by the New York Times. And it's like a data set that looks at military surplus gear that was given from the military to law enforcement agencies. And I think this is like kind of scary. I don't think policemen need rocket launchers. So I was like, okay, why not look into this a little bit more? So the first thing you usually do is read data in, right? So pandas provides a bunch of different awesome tools to do this, right? So pandas.read something, and you hit tab, and you look at what's available. And you can read stuff from SQL. There's obviously CSV files, HTML, Excel. Read table is like tab separated. You can read from a clipboard, which is pretty awesome. So you can copy something from Excel and then read it directly from there. It's really handy. And it's also Unicode sandwich compliant. So if you don't know what the Unicode sandwich is, you should see Ned Batchelder's talk on this. But the idea is that like strings coming into your software should be decoded at the boundary of like what you're doing, and then so they can be always Unicode all throughout your code, and then as they come out, they can be encoded again. So pandas makes it really easy. So here's an example of me reading a file, and on the middle line there, that's not how you spell Mexico, right? So you can just pass in encoding equals UTF-8, and okay, great. Now we got our special characters. And so you might ask, okay, like why, how do I know which encoding am I going to use? And so Chardet is like a pretty awesome tool that does this, where you can shove in some data, and it'll say, okay, with like 99% chance that this is UTF-8. It doesn't always work super well, but most of the time it saves my butt. There's also good old Unix files, so you can run file, whatever the file is, and it'll tell you. And there's also this other tool, Unidecode. So if you want to ever get rid of the special characters in your text, like please don't do this if you like really, really have to. But sometimes you have to like put your code through some like legacy software or whatever that can't handle these. So this comes in pretty handy. Okay, so let's start taking a peek into the data set that we have, right? So this happens to be an Excel sheet, so I'll load up the file, pd.readExcel, and I say df equals. So df means data frame, which is kind of like what pandas calls tables, and that's like the basic data structure that you use for most of these things. And like if you have multiple of these, obviously you don't want to call them df1, df2, because that gets confusing. But if you have one, then that's not that bad. And then you can do df.columns, right? So that tells me what are all the columns in the file. So you have the state of the thing, okay, fine, and the county. NSN, we're not quite sure what that is yet. Item name, okay, so what did they give? Quantity, how many of them did they give? UI, we're not sure what that is. Acquisition cost, so how much money did it cost? And then shipping date, right? Okay, pretty good. So then you could do df.describe, and so that'll give you some summary statistics. You'll notice that not all the columns are here because not all the columns are numeric. But for the numeric columns, pandas will say, okay, here's the minimum, here's the maximum. So like the maximum number of things, so someone gave someone 91,000 things, right? That's kind of crazy. And then the highest cost thing was 18 million bucks, which is crazy expensive. Okay, so then there's another thing you can use called info. And so this will give you a little bit more information about like the types of things. So you'll see that some of these are like objects. And so strings usually end up as objects, and that's like a weird NumPy thing, I guess. And you can see the counts for every single column. So that tells you like that item name must have a bunch of nulls because it only has like 71,000 versus some of them have like 73,000 things. And so this brings me to like an interesting tangent that I want to go on, which is that types are important, right? Like this, if you don't pay attention to this, it can screw you over pretty royally. So 5, the number, is not the same as 5, the string, and it's not the same as 5, the integer, is not the same as 5, the float. And so, for example, here's something where we're reading a CSV file, and the input values are like 5, which should be an integer, and 6.0, which should be a float. And then below, when you look at what the values actually are, because they're same things, because right below in the same column there are values that are null, pandas will have to convert those automatically into a floating point number because for some reason integers can't have null values. And so just be careful and pay attention. And so that's another different thing, is that when you're merging two different data sets and you have like one of them has integers and one of them has floating point numbers, then you can get into these weird things where Python will be like, well, those two things aren't equal, I won't merge those rows together, right? So I'll talk about more of that later. So you can convert types, right? So you can tell pandas explicitly, no, like this is what kind of thing this column should be. And you pass it something called dtype equals. And it's the column name, colon, whatever the type is. And so dtype is a thing that comes from NumPy also. I think it stands for data type. Or you can explicitly convert it afterwards. So you can say df.columnname.asType, and that'll convert that column, which you can then assign back into the column and change the values. So the semantics of types. So types mean different things, right? So there are different kinds of nothing. So data is not available is different than I got a value, but it is 0. So that's an interesting thing to make. Sometimes people will mark the values themselves. So you'll see like n/a, and then some data sets will have like different variations of all of them, right? And then identifiers are not numbers. So like a phone number is not a number, social security number is not a number, right? You can't add two social security numbers together. So it's kind of helpful to think about these things in terms of protecting yourself from mistakes that can happen, right? Like 01605 has an O in the beginning. So if you load it up as an integer, it's going to like chop that first 0. So maybe you want to like make sure that all your zip codes are strings, that kind of thing. And then some variables are categorical, so there are things that are categories, so red, green, blue, orange, or blood types, etc. And then there's ordinal values, right? So it's like categories, except they have a defined order. So you have low, medium, high, and high is always higher than medium, and star ratings are the same kind of thing. And so, okay, so dealing with missing data, this is kind of a big pain in the butt. So you can convert, so I was telling you about how people stick in their own like not available values. And so pandas provides you with a really quick way of specifying those values, and it'll automatically convert them to not available. Or you can do it after the fact if you want with df.replace, right? And then sometimes you want to drop nulls, right? So you have a bunch of null values, and so you can say df.drop_na, and you can see that column C and column D get dropped out. But you'll see, okay, well, how come column A also got dropped out? Is because there's a null value in the middle of it. So by default, pandas will basically drop anything that has a null value. But then there's like ways you can specify, how to do that. So you can say how equals all or how equals any, I think. And then you can also fill null values. So you can say method equals bfill, and it'll backfill the value. So the value that is right after it will get copied in. And then there's also interpolate. So it'll take two values, and it'll take the average of the two values before and after, and stick it in there. So that's also really handy if you don't want any gaps in your data. And OK, so let's start playing around with this a little bit. So you can select columns, right? So I can say dataframe.state. So this gives me a large column, and there's a ... because it's super long. But it prints out some of the values, right? And sometimes your columns will have gaps, right? So item name is not necessarily a correct Python identifier, so you can't just do df.item space name in Python. So there's an alternative way that you can address those things. You could rename your columns, which is also super helpful. But anyway, OK. So then selecting multiple columns. So you can also take a data frame and you can kind of subset it in an interesting way. So you can say, I want a data frame that has only the state and the county columns. And you can do that. So you can pass in different values as an index. And it'll kind of handle that for you. And so this is a theme that you'll see over and over again, indexing, right? So I can take a column and I can perform a logical operation on it, and that'll give me a list. So for example, expensive stuff. I look at acquisition costs and I say acquisition costs larger than 100,000, right? So that'll tell me what is over $100,000. And what that gives me back is a gigantic list that's exactly the same size of the table that I have, except it says false, 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 false. And if it's over 100,000, then at that row it'll say true. So there's a pattern you'll see over and over again in pandas. So what do I do with this, right? What do I do with this column of trues and falses? Well, it turns out you can stick that back into the data frame, and that'll give you only the rows that are the true values. So here are all the things that are expensive. And then you can do count. And so this is kind of handy because, again, it shows you null values. It shows you how many of the things there are. OK. And then what are the highest cost items, right? So so you can do df.sort and pass in the size. Sorry, not the size. The column that you want sorted and ascending versus descending. And so I can see that the largest cost thing for $18 million is an aircraft with rotary wings. So I'm guessing some people got helicopters. And so what are the largest quantities of items? So again, you can use sort for that. And so you'll see, OK, someone gave someone 91,000 electrical wire pieces or something. And then you'll see this interesting thing on the side. Uh-oh. Oops. So there's a column on the side that says UI. And it has a bunch of interesting values. And when you look at, so there's this command called value counts that'll show you the count of how many times each value is used in this column. So you'll see each was used a lot, but then there's EA, and then there's pair, and then PR. And so you're starting to sense an interesting pattern there, right? So OK, let's say we want to replace these things, right? These are not, we want them to be consistent. OK, so you can use df.replace. So you can say, OK, anything in the UI column, if it's EA, then turn it into each. If it's each, then turn it into also each. If it's capital PR, then turn it into pair. And you can do this, basically. And then you can say unknown is np.nan, which means none, basically. OK, so this gives us something a little better. And then we can look at the lowest value. So you can pass in an index just like you would pass for a list. And OK, so we have a skein of something and a E4, no clue what kind of unit that is. But you can say, OK, I don't care about this. So you can say, OK, don't care is all these values that I just selected. And then you can say, I don't know, dataframe.unit.isin. If it's in the don't care list, then I don't want any of these. So you can do stuff like that. OK, that's not what I want. So there are a bunch of other things. So there's regular expressions and other string functions. So you can say if a column contains something that matches a regular expression, give me only that. Or you can you can say a string.lower on an entire column and apply it to the entire thing. And another cool thing is pivoting. So here's an example. Let's say I'm playing some role-playing game, and I have strength, intelligence, and dexterity, and I'm tracking how they change over the days, right? So you have a date, a variable, and a value, and then you can look at how those values are progressing, but that's not a super convenient way of looking at it. So you can change the structure. You can say df.pivot, and it'll actually give you all of the variables for all of the dates. So this comes in handy, and you can also do the reverse operation also. And then there's group by, so anyone who used databases might be familiar with this kind of thing. So you can group values. So I can say, what are the states that gave me the highest, that got the highest amount of money, or things for the highest amount of money. And so it looks like California got a bunch of cash. And OK, so and then the real workhorse here is functions. So you can apply functions to entire data frames. So I can have a data frame, and I can say, OK, here's a function, dataframe.column.map, and I'll apply that entire function. Super handy. OK, so merging data sets is kind of a pain in the butt, right? So like I said, make sure the types match. Make sure the data frame size before and after is the same. Because sometimes you'll merge things, and you'll notice that you have less columns than you did before. And so that should tip you off, saying OK, maybe everything didn't merge perfectly. And so how equals inner and how equals outer basically defines what happens to rows that are not matching on either side. So you can fiddle with that and see. So here is, for example, a table of cats and their ages, right? And then here's another table of cats and their weights. So you'll see that Phoebe doesn't have a recorded weight. So when I try to merge these two things, and I say left on this column, right on this other column, you'll see that it's missing something. But then when I say how equals outer, you'll see that Phoebe is still there, but her weight is just not a number. OK, and then there's a bunch of other libraries. There's Fuzzy Wuzzy and Jellyfish, which basically let you do fuzzy merging, or fuzzy matching, rather. So you can take two strings, and you can say these strings match 90% of the time. You have to do a little bit more wrangling to merge two different tables with this, but it's kind of a pointer as to how you'd go about this. OK, so graphs. This is kind of a big thing. So this is something that I like showing people. It's called Anscombe's Quartet. So here are a bunch of different points that have very, very similar, and I think same for some of them, means, medians, and averages. So if you were only looking at descriptive statistics for each of these graphs, you wouldn't really know that they were different. But when you plot them, you can see that they're super ridiculously different. So that's why visualizing data is important. And there's a bunch of different tools for this. ggplot is the R holdover that someone ported to Python. It's kind of buggy, but I really love it, so I keep using it. Bokeh does interactive plots. Seaborn has a bunch of interesting statistical plots. Matplotlib is kind of the old reliable. It really does everything. And then Glue is one that I really like. So here's an example of Bokeh. So you could have an IPython notebook, and you can have an interactive graph in that notebook that you can zoom in and do a bunch of stuff. And then here's Glue. I'll wait for a few seconds so you can see. So you can select different parts of data sets, and you can have a different graph, and you'll see how it's also selected in that other graph. So you can look at what are the weird outliers and look at it in a different way, and so that gives you some interesting analysis opportunities. OK, so another big thing is that PDFs suck. So if you ever worked in government data, you'll have to extract stuff out of PDFs all the time. So there's this tool called Tabula, which is really kind of like a miracle, where you can go and select a table from a PDF, and that it'll turn it into a CSV for you. And it really is magic. So I recommend that everyone uses. Okay, so scaling up, right? So now you have an IPython notebook, you've done a bunch of analysis, and you cleaned your data set, but like you're getting more and more of these, right? You have, let's say more years of the same data. What do you do? So first of all, don't let notebooks get in the way of reusable code, right? Like I've seen a lot of people forget the fact that like functions exist, right? They keep writing like more and more longer and longer lines, and so this is not really a boon to reusability. And so sometimes repeatability matters, right? Like sometimes you have to run your code over and over again. So just good old build tools help with that sometimes. And if you want something bigger, then there's like ETL tools and data pipelines. So Bubbles is an interesting one by the Open Knowledge Foundation. And then if you're going to go even bigger, there's stuff like Apache Spark and Storm and all that. And so this is a really common pattern that I always do. You don't want to write data cleaning code that is necessarily super specific to the data you have. Like you'll have multiple years of data, right? And all of the years will be like slightly off and slightly different from each other. So what you want is like piece of code A, which like takes a year of data and like standardizes it to a format. And you can have like a tiny bit of code for every single year. And then once you have that standard format, you just kind of like shove it through the main analysis/cleaning system. And this really helps and saves a lot of time. Okay. Another big thing is like you should be conscious about what you load into memory. Like as these data sets get larger and larger, sometimes they don't fit in memory, and it's a pain in the butt. But Pandas provides this thing where you can say chunk size, and you can load data chunk by chunk. And if you really need to go super far in that, well, it also helps to push stuff down into the NumPy layer, so you can kind of benefit from all of the goodness the speed goodness that NumPy provides. So you don't have to, like if you write your own for loops, and that's not going to be quite as performant. So there's some trade-offs there. And if you want to go really further, there's this thing called Blaze that basically gives you a pandas-like interface for querying large data sets. So you can have something in like a Spark cluster or something like that, and you can query it with Blaze, or you can have it in the database. So even if that entire database wouldn't fit in your memory, it'll be really smart about like loading pieces of it and like doing that automatically, so you don't have to do it by hand. So takeaways. So use the proper types for things. I'm really kind of adamant about this. It really does save you a lot of trouble over time. So data has a tendency to be used in unanticipated ways, right? Like you create this data set or you clean this data set, and then there'll be like some other person in your lab who also wants to use this data set. So it's really important to like not only think about kind of like what you're doing, and kind of like think about reusability, but not in terms of only code, but also in terms of the data that you're outputting. And with this comes documentation. So it's really important that you document your data sets. So it's really important, like, where did this data set come from? Like, what's the possible range of values in this column? How was this information gathered, right? So this kind of information is important. Like, I can't tell you how many times we had to toss out a data set because it was like some Excel sheet that was lying on someone's computer, and we couldn't publish stuff with it because we didn't know how reliable it was, we didn't know where it came from. So this kind of stuff really comes in handy. And then a really big thing is like fix data before you need it fixed, right? So the example I had in the beginning, you have a text box, right? If only that programmer had put a drop down there, then like we wouldn't have to go through this data fixing process, right? So there's a lot of information that can be captured while the data is being collected, but is then lost forever once the data set reaches you, right? So that's another thing to think about. And so data cleaning is a necessary evil, right? But it is evil in the sense that like we shouldn't really have to do this, but we have to. So I hope this helps you with that. So what do you think? Questions?
Yeah, I think we have time for a couple of questions. So if you have a question, there's a mic right here up front.
OK. Hey.
Hi. Thanks for your talk.
Yeah.
I was wondering if you're already aware of any tools to help kind of standardize documentation and, say, data dictionaries for data sets now. Like I usually put a data dictionary and some documentation in my README when I upload something, but I've heard that it's bad form to upload datasets to GitHub, depending. So just
Well, I don't know about the bad form thing. That's a really good point, is that I don't really know of any tools. Like, I've been coming up with this weird homebrew thing where, so you can write a data dictionary, and that's kind of helpful, right? But then what's even more helpful is if there was like a nice, easy way to write like a schema. And so that'd be awesome, because then it would be runnable, and you could like automatically check whether the schema is valid and do all this stuff. So I've been trying to build something like that, but not really very far on that. So if anyone else knows one, I would be very interested.
Hi, thanks for the talk. A common practice in data cleaning is something like getting data, changing stuff, dropping some few observations, merging in data. And what I'd love to have when I do that process is a tool that says, I get some text output that says, I did these 20 things to this data set, so I know what's going on. Do you have strategies for doing that?
Oh, that's also a really good question. So it would be like diff for data sets, kind of.
Yeah, and it could be like commented code that I run a program over to pull that out. But it's been a common problem when I do data analysis that this is hard to get by just getting an overview of what changed in my data.
Yeah, that's also another really good question. I'm actually not very certain about that either. Okay, a lot of good ideas though. Yeah. Yeah, I mean, yeah, definitely. So I encourage people to provide their code along with their data sets, right? I think that's a really big thing, because that's like tells you in non-ambiguous terms exactly what happened to this. And so I would prefer that you'd have like the complete raw data set, and then you would have like a rerunnable process that other people can run and do their tweaks and that kind of thing.
Unfortunately, we're out of time.
Right.
But if you have questions, you can come talk to Mali after. Thank you so much for your talk. It's great.
Thank you.